Well, welcome back. We have 8 weeks left. You're halfway done. 8 weeks, and this week, at least here in Nebraska, is supposed to be amazingly beautiful, which, knowing the weather forecast, probably means we'll get a snowstorm, even though it's supposed to be 70. Who knows? But, so, week 9, let's take a look at week 9 really quickly. Just kind of reinforcing, we kind of stopped on chapter 4. There's a lot of stuff in chapter 4. So we're gonna pick back up where we left off. So we've got some programming exercises, and we've got some pieces we need to look up and pick up. I moved a couple of assignments back over here, and this chapter has a lot of things we're going to talk about. Text strings, and we've looked at a little things we can do with those. We've looked at a little bit of looping, but we're going to introduce some other pieces here. So hold tight while we introduce you to some of this stuff, and I'm going to throw it up here in the box here. So I'm going to jump around a little bit and just kind of talk about some of the things that we went over. So hopefully my voice will hold out. I got some kind of a little cold or something over the break, and my voice gets a little croaky. So we talked about how a string is really a set of items, and we can use the substrings. So in other words, we can pull things out based on their position. And that becomes really important. It's a great tool we can use. So we looked at how we can rearrange data. So we forced you to do an encryption and decryption program. And how you can slice things and take a length of things and look for things inside of a string, which is kind of a really neat way to do things. So just kind of running through that real quick. And so our data encryption and decryption, we talked about using something like a Caesar cipher where we rotated around that idea of what was that value. So, no, please come in and hang out. So, there's other ways we can do it. And so, there's some block ciphers and other things. And so in cybersecurity and other classes, we talk a little bit about how we can encode data. One of the things we need to look at is our computers are really, really dumb. And we know that it's just a set of switches. But we need to think about what kind of number systems we're using inside of our computer. And our computer actually, and I'm going to highlight it here, our computer, everything we do is in binary inside of there. But we don't read binary very well. We do decimal. Maybe because we have 10 fingers and 10 toes. But whatever reason it is, our brains are acclimated to binary. Our computer wants binary. We want hex or a base 10 decimal. There's a couple of other ones we use. And so the other one we use fairly frequently is called hexadecimal. And hexadecimal actually goes the opposite direction. So base 2 says there's only 2 characters, zeros and ones. Hexadecimal says we have 16 characters, and we go 0 through F. We actually have to add some more symbols in because we have 16 different characters. And there's some advantages to that because we can represent large numbers with fewer number of characters. And you're starting to see that a little more. If I do take my computer and I open up a command prompt and I put in ipconfig all, what you'll see is there's some weird looking numbers in here. And when we talk about IPv6, this set of strings is an address for this computer. But that address is so big, to actually fit it even into this nomenclature, these are actually all, each set of these is actually a hexadecimal pair. So it doesn't look evident at the beginning, but here we have a number called 6F, 7E, E0. Well, what that does is it allows us to represent a bigger number set. So because I can go all the way to FF, which is equivalent to 255, I can represent more data And our computer can translate very easily from binary to hexadecimal. There's not an issue with that. So we see this hexadecimal a lot. So a number like this. The one we haven't talked about, and really doesn't get used a whole lot, is called base 8 or octal. Honestly, while our book talks about it, I don't have a lot of use in it. I haven't seen it used a whole lot. It's kind of an intermediate step. Typically, I see binary, I see decimal, and we see hexadecimal. So we see these different number systems. So the book talks a lot about how to convert positional systems, and we'll look at how this works. So the same way that we have positional values in decimal, so our ones counters, our tens places, our hundreds places, well, we have the same thing in a positional value when we're looking at something else. So this lets us convert from binary to decimal really easy, because we know we can multiply by 2. And so this value here, 1, 0, or 1, 1, 0, 0, 1, 1, 1, is in, and we put a subscript in to say that it's in binary, but it's pretty common. So one thing I will say is typically, so there's a leading 0 up here that we should probably represent. Typically we show binary in groups of 8, so, or 1 byte, B-Y-T-E. So we will typically show that. And what you can do is convert back. So we know that we have, this is the 1's position, 2's position, 4's, 8's, 16's, 32's, 64, and finally this last one would be the 128th position. So if I'm going to convert back, I like to use something like Excel. I'd show it up on the board, but I can't really do that, so I'm going to pop open an Excel sheet here. And I know that those positions, so I'm going to say that I have a number. Let's just grab one there that's in binary. Again, I put in all 8 characters. And so what we can do is we can create a chart, and I know that this leftmost position is 128, or the position value, 64, 32, so I don't need to memorize those. Now, I did it backwards, just so I could start from left to right, but in this value, I know that if I start by 1 and I multiply by 2, I get all the way over here to 128. So I'm going to take this number I've got here, and I'm going to put it into, so this is my placeholder, or place. And I'm going to take this number, and I'm going to break it down and distribute it across this. Excuse me. So, first one has a 1, 1, 1, 0, 1, 1, 1, 1. Well, this lets me easily say in which places I'm going to move a value down. So I'm going to say, all right, yep, I'm going to move down 128. I'm going to move down my 64, my 32. I'm not going to move, that's going to be a value of 0. 0 times 16 is 0. 8, 4, 2, and 1. And if I add these all up, that value that I get will represent what this is in decimal. Alright, so if I do that, I'm going to cheat here just because I've got it handy. That says this value is 239. Oh, well that's kind of handy. I can even automate this if I really wanted to. Because what I could say is I could say this is equal to this times my position value. I could take that, move it across here. Undo, because I can't. Go back a little bit. Alright. So now, what I did was I just created an automated way to do this for me when I can break this down by position. So if I change that number, and instead I said it's 1001010. So I go back in here, I put 1, I put my 0 in, 0, 1, 0, 0, 1, 0. Look at that. It automatically calculated that for me. But all I have to know to do this by hand is remember that I can multiply by 2. So I can go this direction pretty easily. Well, let's go the opposite direction. And I want to convert a number. So let's convert 221. And I want to convert it to binary. Well, this is where it's almost easier to show you on the board, but again, I can't do that very easily. But what I can do, though, and so I'm going to take this out, delete it really quickly, and I'm going to delete all these. So 128. So what I'm going to do is a little mental math here real quick. So is 221 bigger than 128? I hope so. So I'm going to put a 1 in here, and I'm going to subtract 128 from it. And so when I do that, I'm going to get a value. And again, you could automate this to some degree if you really wanted to. But I subtract the two of them, and I get 93. So 93, is it bigger than 64? Yup. So I'm going to put a 1 in here, and I'm going to subtract a 64 from there. So now, and notice I could actually just copy my formula if I really wanted to, if I were doing this by some other method. So 93 minus 64, and I get a value of 29. Well, 29 isn't bigger than 32, so I can't subtract that out again, so that becomes a 0, and I move to my next one. So it is bigger than 16, so I can take 16 away from that, and 16 out of there then should be 13. So I have a 1 here. 13 is bigger than 8, so I'm going to put a 1 in there and subtract 8 again. So that should give me 5. 5 is bigger than 4, so I'm going to take another one out and subtract that 4. So I'm just kind of working my way through here. So when I get to, I have my 1, well, that one becomes a 0. It's not bigger, but it is equivalent to that. And so that tells me that my decimal value for 221, and I left this step in here so we can double check ourselves, that should be 221. And so in binary, it's 1101, 1101. Oh. So we can convert back and forth based on those placeholders pretty easily. Well, there's a couple other ways we can do it that are even easier. Understanding how we do it. So our handy dandy, holy cow, that's big. Our handy dandy calculator, if I click to programming mode, notice what it gives me right here. So if I put a value in and I say I'm going to have a decimal value, notice what it does for me. It converts it to hexadecimal, decimal, octal if I wanted to use octal, or binary. And so it's kind of a handy thing, this programming calculator that's built into Word, or built into Windows now. So we can get it to do some of the dirty work for us also. But it's helpful to understand how that structure works. So typically we have 8 characters, and is the way we display binary. So the biggest value would be all 8 ones, and that's going to equal 255. And all zeros, that's going to equal 0, right? And notice what it did. It collapsed it down when I tried to do that. So I'd have to put in a quote mark to show it. So we'll 1, 2, 3, 4, 5, 6, 7, 8. So this is binary and this is decimal, and they interact in that way. And we see that. So if I go back to my command prompt here, you think, well, I'm going to scroll through here and I see these things up here. We call them IP addresses. 10, 20, 17, 21. There's a subnet mask, and they're all this group of values. But these are actually decimal values that have already been converted. So our IP addresses are really binary. So if I ever see an IP address that says it's 355, somebody is fooling me because it's not. So if I see some TV show and they're typing in, my IP address is 355, 28, 41, 37, it can only go from 0 to 255. So Excel can do this, and we can get into our programming language and we can also start looking at it. But I think the Excel makes it a little easier. That's essentially what they're doing here, but I think it's a little easier. So they also show how to convert from binary to decimal using the computer. So one of the things we're going to do with this, so we take our string of bits, we take our decimal, and here we're taking that length and we're using it to figure out the value of all of these as we go through there. So enter a string of bits, the integer value is 15. So this is another way you could do this. You could actually write a program to do that programmatically. And we could do the same thing when we're going decimal to binary. We're repeatedly dividing a number by 2 is essentially what we're doing. And we're putting out this quotient that says, here's our decimal value for it. So as we go through those I think will be kind of handy to do. So 34, and this just shows the math as we go through it. So 34 is 100010, but really it's 01 if we hold it to that strict 8 conversions. So quick conversion chart of some of these items about where they flip. Again, I don't do a lot in Octal, so we're not going to do a ton with Octal. Octal converting to binary is pretty easy because essentially they're both powers of 2. We don't have to worry about how we get them. No. String methods is another interesting thing we're introducing. So a string method says a lot of our items already have built-in things we can do with them. So a method is a kind of like a subroutine or a module. So for example, if I wanted to split something here, I can split this name, myfile.txt, splitting it at the decimal. So we can actually split something into 2 parts pretty easily. Well, what I'd like to do is be able to read and write to my computer and find these files and actually look at them. So, writing to a file is pretty easy, but the problem is this. This seems to be a new struggle that I've ran into for students, and it has nothing to do with anybody's ability to recognize objects. It has to do with we're so conditioned with the use of our phones and things that our files just get stored in a blob, and we don't know anything about that blob, where they're stored at. On our computer, I have to figure out where things are stored. And so, for example, here, I have to say, all right, I have a C drive, and I have to go to users, and me, and desktop for documents. So I have to know where things are stored. I have to know that file structure. And I know from our 101 classes, I know from the web design class, this is something we're not used to doing. And here's why it's going to become important. So if I write a Python file, so I have a file in this folder, and I want to create a new file and put it into this folder, I have to know a little bit about where it's at and where my program is stored at. So I'm going to move over here for just a second, and I'm going to open idle. So idle will let us do way too many things open here. So if I do the same thing what I'm seeing here, so F is just a value we use just because we're shortening up the word file. So open, and we're going to open a file. So when I type in myfile.txt, that's the name of the file I'm going to open, and this W is really going to say, if it's not there, go ahead and create it. Well, here's the problem. So I'm running this in idle. It created a file somewhere on my computer called myfile.txt. But I don't know where it is. I am not pointing in necessarily the right spot. So it didn't put it here magically for me. So I'm going to go to my computer, and I'm going to see if I can find my file and see where it actually put it at on this particular computer. Because I don't know where this shell is actually going to save things at. So that may take it a little bit on this poor thing. So we created a file, and I can actually do something to that file, but I have to be able to figure out where that file is at. And because it likes to store things in these weird temporary spots, I'm going to suggest that what we really might want to do, just copy this real quick, so I have to retype it. So if I go to a new file, and I write this as a batch script, let's put some comment on the top here that says, this file creates a file. Well, that's really iterative. But I need to save it in a specific place. And so I'm going to do the save as, and I'm going to say, I'm going to save this under my documents, under Python files, and I'm going to call this write. So now it's got a name, I know where it's at, and so if I run this, run module, it doesn't really display anything because it didn't do anything very exciting. All right, so let me stop this search because it finally found it here. So let's see, it went to this folder called app data, which you can't really see very easily, local programs, Python. So it did actually create this file. It's just not very usable for me. So I'm going to encourage you to go into the batch mode where you can tell where you're going to save something. So now I've saved that file. Well, let's go look and see if it really exists. So I'm going to say Documents, Python Files, and it did. It created a text document. Now that text document, as we see, is blank. There's nothing in it right now, but that file didn't exist before. Ah, well that's kind of cool. So let's put some content into this file. So let's change this up just a little bit. And we're going to use another one. We're going to use f.write. So again, that's that method idea. We're using f.write. And this is what we're going to put in there. First line. And we're going to put a new line command in there. We're going to end it with a new line command, just out of curiosity. And then we're going to do one more, because we opened something, we really should close it. So f.close. All right. And notice these methods take data in or out, so they're always going to have a parenthesis with them. So now I'm going to run it, and it's going to say, do I want to save it? Yes. Again, nothing appears on the screen. We didn't really do anything that printed an output. But what I want to look at is, did my file change? And notice it was 0 kilobytes before. Now let's take a look at it. So I just wrote a file from a program I just wrote to a text file on my computer. So that's kind of cool because now I can create content. So maybe I want to store high scores for a video game. This is one of the ways we can do that. We're going to create that file. And it's pretty easy to do. This didn't take a lot of effort to create. So it didn't take a lot to create, and I can put information in there. So I could create a loop and store the values 1 through 10 in there, or I could do all different kinds of things, but that's all I'm doing. And if I said, let's do it this way. Steal this. So I'm going to say sentence equals. All right, so we created our file. It wasn't that horrible. We said we're gonna create a file, and it's pretty easy to do. Well, if I can create one, so we could also write numbers to it. And so this example says we're gonna create a file called integers.txt, and we created a list. So I'm gonna cheat just a second here because this makes life easier. Look at that. The thing I will tell you never to do is cut and paste. I'm going to do just to demonstrate this. So we know that we need to, if we're going to use random, we have to import it. So in this case, it's going to create a file called integers.txt. And it's not going to work because I'll show you why here in a second. The quote marks that it does when you copy and paste are different. If you notice, it actually had the ones that went to the left and to the right. That will always cause an issue. So what we're going to do is we're going to do a for count in range 500. So it should create a loop of 500. And then we're going to create a number between 500. So let's see what happens when we run this. We have to save it, so I'm just going to call it the same thing. Oh, hang on. It's going to not like that. Try it again. Nope. And it also is going to do tab. Okay. Try it one more time. Nope, and it's not going to like those either. The marks they use in a lot of the text authors, the way they do it, just work a little different. Alright, so it doesn't look like it did anything, but let's go take a look and see what it did in that short amount of time inside this file. So, it created a file called integers, and it must have some data in it because it went to 3 kilobytes, which tells me that it actually did. It wrote out 500 random numbers between, and in that amount of time. It's kind of amazing that it can do it that quickly. We can alter this program. So the other thing that will happen is when I rerun this, it's going to write over the top of this existing file. And we can show you some ways to not do that or to add it to the end so we could do it as an append. But let's change it just a little bit. So if we wanted to do this for 5,000 numbers, and we wanted them between even bigger values, so between 2501. It's going to say, do I want to save it? Yes. Chunk. And that quick, it has written that file out. And in fact, if I go here now, notice it went to 28 kilobytes in that amount of time. And so now there's 2,500 numbers, and it reads and writes them that fast, in literally a blink. So, but what it did, though, if you notice, when I look at that, even if I go up to the top, I think, well, no, it completely rewrites that entire file each time. So, just something to keep in mind, at least the way we're showing you here, what we can do with it. Well, the same way we can write to one, we can actually read. So we open the file, and we then say, all right, we're going to open it, and then we have to figure out how we're going to do something with it. So we can read it by a single line. We can read it the entire file in. So depending on the type of file and what we're doing with it, it may vary how we want to do it. So this example, the read method says I'm going to read, and each fread reads one line. So that's handy, but maybe we want to do a little more. And when we, at the last one, so if I used a loop, so here we said for line in F, and when it gets to the end, it says here's an empty string, and it's actually going to stop reading from that. So there's one called read line. So there's a lot of different methods that we can get to work on that. So when we start practicing these, it'll make more sense. So in this case here, this one we're saying we're opening this integer, and then we're adding them together. So there's a lot of different methods. So this is a shortcut for some of the things that we're going to do. So open, we always have to open a file. We can open it with read, write, read, write. So in other words, it can both read and write a file, or append. Append says, I'm going to add it to the last piece. So if I had taken this program I had here, and instead of saying write, I said I want to append. Well, when I append, so now if I run this, instead of starting over with a value and set of numbers, now it's going to add another 5,000 at the end of that. So if I go look at my file now, look at it. 55 kilobytes, because now it's got 5,000 lines in it. Or 10,000, because we've done it a couple of times. So right there, oh, 10,000 lines in there. And you think, well, maybe that's just a bug. Let's do it again. So that append can be really valuable because I can just keep adding on to this file. And now it's up to 82 kilobytes. So if we scroll all the way to the bottom, scroll all the way to the bottom, look at that. We now have 15,000 lines in this file. So it's a handy way we can put data in and out of these. So the append we use actually a lot, because that way we can take an existing file or a file we've created and add to it. So close. Anytime we open a file, we're going to close a file. Now, our book says it's not needed if you're just inputting. It's best practice. Just close the file. There's the fwrite, fread, and freadline. And there's some other ways we can do it also, but for now, we're going to just use these two. So this takes a line of text, returns it as a string, and both of these are ways we can pull data out. And you'll see that when we start looking through those. There's some content about directories and how they work. So you can actually go up and down. So the same way if you're in 410, we talk about that relative addressing where we can relatively go up or down. We can do the same thing in Python. So this is the child folder. Here we can go up with the dotted notation and or sideways. What I'm going to say for this class, I'm not going to get that involved. I would put it all in the same folder. Everything we do you can put the file in the same folder and make your life a little easier. But all right, so we can even interact with other files on there. So we can open a file and actually run it, which is kind of crazy. So down here, there's a couple of things we can do. So there's an OS module we can import. So we can do things like change directories, figure out where I'm at in the system, list directory paths. So if you're going to do anything nefarious in Python, so maybe you're trying to substitute passwords or overwrite things, this is some of the stuff where you would do. But for now, I want to move on to the book a little bit. So notice I moved this assignment back over here. So I said 4-3, and we're going to take a look at it real quick. Start. Somewhat slowly. All right. Modify the scripts of project 1 and 2 and decrypt the entire files of the text. Oh. Okay. So, example is shown. Enter the input file name. So we're going to look for something called encrypted text. We're going to, the file name, the output file name, where we're going to put it, and enter the distance. So, same thing as what we did before, except now we're actually going to save these into a couple of files. So, here's actually our code to start with. So, 4-3, we're going to take a look, and let's see if, back this up. So, let's see what happens when we run. Yeah, missing parenthesis and all different kinds of things. Okay, so we need to figure out all right, so we have a couple of other errors. So we need to look at this and probably figure out what we can do to create a program that will do this correctly. So, to get there, we need to start with what these encrypt and decrypt files should possibly look like. So, my encryption program, let's make sure it works first. Enter a one-word lowercase message. Enter the distance value, and I'm just going to put 1 in. We can see if it works. And it says, oh, okay, so H, F, okay. So my encryption program works. So I need to figure out why my decryption one didn't and work from there. So these assignments start building on each other a little bit. Okay, way too many windows open. Let me close a couple things here. Just get them out of the way. Nope, wrong one. There we go. All right. So we need to have both a decrypt and encrypt program. And we need to figure out what we're going to do so we can create one program that's going to do everything we want it to do. And I know that seems crazy, but let's take a look and see if we can come up with a piece of that. So, I want to enter the input file name, okay, encrypted text, enter the output file name, and enter the distance value. So that's what we need to have as a interface. All right. So, no, I don't want to package or whatever you're talking about. All right, so we need a couple of things to start with. There we go. Okay, so let's make this as big as we can. So the encryption piece seems to work so far. So we need to modify it a little bit, because what we'd like to do is we're going to take this input and we're going to actually save that to a file. So I'm going to do a couple of things to make life easier for me. So I'm going to work on the encryption one first. That seems easier, or the way to start. And I'm going to get my code here. And I'm going to say, this is my input stage. My input stage, I need a couple of things. I'm going to enter the input file, the output file, and the distance. So the distance we already have down here, so I don't need that necessarily. And because we're taking it out of a file, let's see if we can correct a little bit. So the in file name, and I'm just going to shortcut to in name, put enter the input file name. All right. Enter the input file name. It's already coming in as a text file, so we don't necessarily need to do anything with that. Our next question is, I'll just call it out name equals input, enter the output file name. All right. And then last, we're going to put that same one we have down below. So I'm just going to bring it up. So distance equals. All right. So we've got a file name. We've got where we're going to write it to. So now we have to come up with a few other pieces in here. So code isn't going to equal anything because we don't know what that is yet. So let's see. What are we going to call this? Let's break that up so I can say file, open, and read. So input, let's call it input file. That makes sense. Equals open. And here, instead of, we don't know the file name because it's coming out of up above here. So that becomes in name. And we are just looking at it to read it, so it's just an R for read. And then our plain text, I think that's what we called it in here. Cipher value equals, well, we can do it that way. Let's call it our plain text. Plain text is then going to equal input file.read. So it's going to take whatever's in that file, spin it in, and that's going to become what we're going to then look at. So our output file then so we've opened it. I need to then figure out where am I going to store the output file. And if we just said in file, then we could just do out file, just to keep it easy. We're going to open, and up top we called that out name. And we're going to store that, so we're going to create a write command. So now we've opened a file to write to. We haven't wrote to it yet. At the very end of our encryption, so instead of just outputting that code, so instead of saying print code, we can actually store that inside a file. So, outfile.write, and then we pass in our code, whatever we created in our encryption, and then outfile.close. Now, our book says we don't need to close this one that we opened here just to read it. I'm going to say I like to close it also, just out of sheer habit. So now, what this should do, if I run this encryption, it should go out and it should say, all right, I'm going to open a file. I am going to then take the data in that file and I'm going to scramble it and output it to another file. The only questions we get then are, so the file name, so our input file name, and we don't have one right now, but we'll have to create one. And we're going to scramble that. So they called it encrypted.txt. Enter the output. Now, it says, hey, none of these are found. So we've got to do a little more work on that. But we'll start on that, and we'll do a workday then on Thursday. And we will finish this up and show you how we can store those files inside of here, and we can work on those. All right.